Writing an equation of an ellipse given the foci and major axis length. All right, for these problems, you're going to be given the major axis length and the foci. So the first thing you're going to need to determine is which of these two equations you want to use. Okay, now the difference between these two equations is where the a squared and the b squared values are. And that has to do with the major and minor axis lengths. So we know HK is our center. A is the distance from the center to either endpoint of the major axis, so from here to here. So our major axis is the longest axis. So if A is the distance from here to here, 2A is the length of the major axis. B is the distance from the center to either endpoint of the minor axis. Okay, so in this case, here's my minor axis length. Here's the B value. And so from one endpoint to the other endpoint on the minor axis is 2b. C is the distance from the center to either of the foci. So in this case, so from here to here, or from here to here, so from one foci to the other, that distance is 2c. Okay. You are also going to need this formula right here, b squared equals a squared minus c squared. So let's go ahead and look at those problems. So the first thing I would do when you're given this problem is kind of sketch your foci and determine the direction of your major axis. Does it go in the y direction or the x direction? So in this case, the point 5, 4, I'm going out to the right 5 and up 4 is right here. And then 5, 0 would be right here. And the center would be a point right in the middle of those values. So that means my major axis is going to go in the y direction because that's where we have the foci. Okay, so something like this. All right, so the distance, again, from the center to this endpoint is my a value. Remember, if our a value is going in the y direction, then we're using this formula here, where the a squared is below the y minus k quantity squared value. So the center is basically the midpoint of the two foci values. So now if you remember how to find the midpoint, you're basically finding the average of your x values and then the average of your y values to find the center. So if you take 5 plus 5, these two x values, add them together and divide by 2. So that gives me 10 divided by 2, which is 5. So my center, the x-coordinate of my center is 5. My y-coordinate is 4 plus 0, which is 4, divided by 2, which is 2. So the center is the value 5, 2. So this is my HK value. Now A is this distance here we were talking about. Okay. Now we know the major axis length is 8. So all the way from this endpoint to this endpoint is 8. So half of that would give me A. So I just basically divide this value by 2, and that gives me A. Okay, so the only other thing I need is B. I need my B value. So this is when we're going to use the formula b squared equals a squared minus c squared. So make sure you have that handy. And let's see, we're trying to find B. We know that A is 4. And we can find out what C is. Remember, C is the distance from the center out to the foci. So C is this value right here. Okay, so if we know the center is 5, 2, and we know that this point is 5, 0, right? What's the difference in our y values? What is the distance from here to here? So if we take 2 and subtract 0, that's going to give us our c value. So now we can plug that into our formula, minus 2 squared. So we have to do our exponents before we can subtract. So 16 minus 4 is 12. So b squared is 12. we really only need b squared for our equation, so we're going to leave it in that form. So we have x minus our x coordinate of the center, which is 5, quantity squared over b squared, which is 12, plus y minus our y coordinate of the center, which is 2, our k value, square that, over a squared. We know a was 4, so we square that to get 16, and that equals 1. And this is the equation for the ellipse that has major axis length 8 and foci at 5, 4, and 5, 0. Let's look at another example. In this example, the ellipse has a major axis length of 12 and foci at 9, negative 4, and negative 1, negative 4. So at 9, negative 4, so to the right 9 and down negative 4 is one of our foci, and a negative 1, negative 4 is another. So that means our ellipse is going to go in this direction. Okay, and so the center is right in between those two values. So we need to use the formula where the a value is underneath the x coordinates, because we're going in the x direction. So we're using this formula. All right, so let's figure out HK first. So HK, again, remember, is the midpoint of these two foci values. So we add these x coordinates together and divide by 2. So 9 plus a negative 1 is 8. 8 divided by 2 is 4. Now we do the same thing with our y values. A negative 4 plus a negative 4 is a negative 8. Divide that by 2, and that's a negative 4. All right, so that's HK. Now A is the distance from the center out to one of your endpoints of your major axis. Okay? And we know that all the way across from one endpoint to one endpoint is 12, so half of that is 6. So A is 6. All right, and then we're going to use this other formula, b squared equals a squared minus c squared, to find out what b is. So the first thing we need to do is find out what c is before we can do that. So remember, c is going to be the distance from the center to this focus here. And so this focus point here was the point 9, negative 4. And so you can see, instead of doing the difference between the y's like I did in the previous problem, I'm going to take the difference between my x coordinates. So 9 minus 4. And that's going to give me 5. B squared equals a squared, which is 6 squared, minus c squared, which is 5 squared. So 36 minus 25, and that is 11. Okay, so let's plug our information into our equation here. So the x coordinate of the center is 4 over a squared. And a was 6, so this is 36, plus y minus negative 4. So y minus a negative 4 is going to be y plus a positive 4 squared over b squared. And b squared is 11, and that equals 1. And this is the equation of the ellipse with major axis 12 and foci at 9, negative 4, and negative 1, negative 4.